Folks, so now we're moving to quadratics, and for this part of the final, there are two sections. We need to know the properties of the graphs of quadratics, and we also need to know how to solve them. So 4.1 and 4.4. So we're going to start with the key features of graphing. In order to graph a quadratic, what's the first thing that we try to find? The axis of symmetry. You must show the work for that on the test. And that equation for the axis of symmetry is just the first part and then part of the quadratic formula. Quadratic formula is negative b all over 2a. So negative b over 2a. Careful with your signs there. So axis of symmetry takes me to the vertex x value. So this value that I get for the axis of symmetry gives me the x value of my vertex, which I can then plug into the equation to find the corresponding y value. Remember the x equals with your axis of symmetry. That is a vertical line equation that cuts the graph in half. Your zeros are your x-intercepts. They're your roots. Y-intercept, we can read that directly from the graph. Axis of symmetry equation, I'm going to write that again. X equals the vertex and behavior notation again. So you have to know that for two sections of the test. So again, making sure you've got that memorized. And then domain and range. Make sure you read your graph scales carefully. So read graph scales carefully, so that you can figure out what your domain and your range are and those corresponding points. On this page, it's not going to make a difference, but on the next page, when you actually go to do the graphs, after you find the vertex, you center it in your table. So you make an XY table. I'm going to be looking for that table as part of your work. Vertex is in the middle. And we keep going with values, so keep going until you catch the x-intercepts. So keep going until you catch the x-intercepts. Careful with the x is between two values. You may want to study that part from our note packets. So when we get that between, it either means we are getting a fractional x-intercept, or it could mean that we are getting an irrational number. But when we are solving by graphing, you only need to state that the x value is between something. So that takes us through the next couple of pages. Also, just put a star by number 21. It's very, very important that that -2 stays on the outside when you are plugging it in on your calculator. And that's all I really wanted to talk about for that section. Again, this is the more recent section that we did, so I think that part should go fairly well. But now for the solving quadratics. And this is where we start at the bottom of page 9. Let's see. Where do we have good work? I think I actually want to go back to page 8 and kind of write the process for this over here. So we'll write 4.4, solve quadratics. So this is bottom of page 8. We're just going to write down some things about solving. So first, what's easier to use when solving? Factoring or the quadratic formula? Factoring for sure. So we always want to try to factor first or look at our graph. So factoring is easier. Don't forget to check for a GCF. So GCF. Let's throw a difference of squares on there. and the x method. Now, once you get it down to factors, something times something equals 0, don't forget that you're actually trying to solve and figure out what x is equal to. So let's say I got x plus 2 and 3x minus 4. I'd have to set this equal to 0. I'd have to set this one equal to 0. So x equals negative 2. 3x equals 4. And x equals 4/3. So these would be my two solutions. So on that test, I did have some people who stopped at the factoring. Since we are solving, we want to take it all the way to those x-intercept solutions. Now, that's if we can solve by factoring. What happens if it is prime? Or what happens if we give up and can't factor it? Then what do we do? Quadratic formula. First, you got to know the quadratic formula by heart. I think I'll do the same thing that I did on the test and have you write it first just to make sure everybody's using the correct formula, and you will get points for knowing it or not knowing it. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's the first step, is knowing it. Second step is knowing how to use it. So where do we start simplifying the quadratic formula? We start with the stuff under the square root, which we call the determinant. That's step 1. Step 2 is simplify the square root itself by taking out perfect square factors. Step number 3, division distribution. And step 4, which you won't always be able to do, is the plus and minus case. This is only if your roots are rational. Which means if you get radical 2, not going to be able to do the plus minus case. If you get 2 plus or minus 5i, you're not going to be able to do the plus minus case with that because you cannot combine those like terms. So this order is very, very important. I would put some stars by this. The order of those steps is very important. You cannot divide stuff out of the radicals when you do division distribution. If you need extra practice with this, remember that green packet we did? It's like 4.4 intermediate quadratic formula solving. I have extra packets of those. Those are great things to do if you are unsure of step 3 and step 4. So we want to try to factor first, but when in doubt, quadratic formula. Don't forget though, you can use your calculator to check. But only to check. Only for checking. You have to be able to show the quadratic formula work, or you have to be able to show your factoring work. If you just say my solutions are 4 and 5, that is not showing me that you know how to solve by factoring. But you can use your calculator as a tool for helping you. So folks, we're going to be referring to that chart as we start going through some of these quadratic formula ones. So let's go ahead and look at number 25. Ooh, there's something else we're going to have to add to the previous page, because why aren't we going to try to factor this right away? What's not okay coolio about this? It's not in standard form, and our A value is negative. Not great for factoring. So let's see if we can squeeze this in here. Before we try to factor, it needs to be in standard form first. That means ax squared plus bx plus c equals 0, and that a value has to be positive. Doesn't have to be positive for the quadratic formula, but for factoring, that a value has got to be positive. So let's go ahead and flip back to number 25. And we're going to put this in standard form first, and we're going to get that a value to be positive. So I'm going to add 8x squared to move him over to the right side. I'm going to subtract 5. So now we have 0 equals 8x squared minus 4x minus 5. This is not my absolute favorite quadratic to look at. I think it's going to be kind of nasty to try to factor, but we're going to go for it. We're going to try all possible combinations. So I'm going to start with my factors of 8 that are closest together. So 2x and 1x. And let's do 2x and 4x, my bad. 2x and 4x. And then 5 and 1. 2x times 1, 2x. 4x times 5, 20x. Is that going to get me to that sum of negative 4x that we want? That's a no. We flip them, 1 and 5. That gives me 10x. That gives me 4x. Yep, that's not happening either. So what do we do now? We try my other factors of 8, which would be 1 and 8. So I'm going to do 1 and 8, 1x and 8x. So this times the 5 would be 5x. 8x times the 1 would be 8x. Ooh, we're close, but that's still not going to get me 4. So that's out. Let's try flipping this one more time. That gives me 1x. That gives me, 40x. Yeah, that's a no. So what does this tell us? It's prime. Do we give up and just say we're done? Yep. Nope. We got to use the quadratic formula. So I'm going to be plugging in simultaneously while singing the song. X equals negative b. Make sure you're using standard form. So negative 4 plus or minus square root of b squared, parentheses around that, negative 4, minus 4, 8, negative 5, all over 2 times 8. So those parentheses, that's important to start by this problem. Without those parentheses, your discriminant goes wrong. When your discriminant goes wrong, the whole freaking problem goes wrong. So let's go ahead and start here under our square root with negative 4 squared minus 4 times 8 times negative 5 is 176. Wow, I do not like that number. Okay, so x equals positive 4 plus or minus square root of 176 all over 16. What do we do next? We have evaluated the discriminant. What's our next step? Not division distribution. Simplifying that square root. Now, I don't know about you guys, but off the top of my head, perfect square factors of 176, I don't know. It's even, so I'm going to try dividing it by 4. Ooh, so 4 is a perfect square factor. But I can take a 4 out again from 44, which leaves me with 11. So if I can take 4 out twice, what's the biggest perfect square we can take out of 176? 16. And you can try that. 176 divided by 16 is 11. So I'm going to break this down into its perfect square factor, which is the 16, and the non-perfect square factor, which is 11. Notice that these are both still under the square root at this point, because radical 16 times radical 11 is radical 176. I am not ready to division distribute yet. So 4 plus or minus the square root of 16 is 4. I'm still simplifying the radicals. Over 11 and then over 16. Can I simplify the radical any further? Nope. So now we're ready for division distribution. 4 divided by 16 is a fourth. Plus or minus this 4 divided by 16 is also a fourth. So 11 over 4. Hey, can I actually add those together? Nope. Can't add that radical stuff to that rational stuff. So those are my answers. That stuff equals x. Now here's what's super fun about this. You can use your calculator to check yourself. So I'm going to go to my calculator. I'm going to type in that standard form equation, 8x squared minus 4x minus 5. I'm going to look at the graph. I see that I have x-intercepts, so that's good. Now, if you're nervous and it's like, that one looks like it's right at 1, Mr. Cairo. If I hit trace and try 1, we see that it's actually at -1. Now, using the trace button, I can type in 1 divided by 4 plus the square root of 11 over 4. And what should I get for the output? 0. 0 exactly. So you can check your rational roots and your irrational roots using your calculator to verify that they do give you an x-intercept of 0. This is also useful because what if my graph was floating above the x-axis? Then we should know that our solution should have involved I instead of just having a regular square root. Folks, what questions do we have on that one? All right, I'm turning you loose on 26. Yes.
Why'd I come this way? Excuse me.
No.
I almost ran over late though.
One, you can leave it like that. Yep. Final's about 20 questions, FYI, but some of those questions, like this counts as one question, a linear programming problem counts as one question, so some of them are big questions, but it's about 20 questions. All right, folks, so let's see how we're doing on 26. It's in standard form. Love it. Can I take out a GCF?
Yeah.
No. So we try to factor it. And if you're like, I don't want to try to factor it, Mrs. Cairo, you don't have to. If you wanted to go straight to using the quadratic formula, you could. And actually, if I type this in on my calculator, 3x squared minus 3x, whoops, let's try that again, minus 3x plus 8 There's my quadratic, and it's not touching the x-axis. So what do we know about those roots?
None.
They are imaginary. So you can try to factor, but you'd find that it's prime. Or you can look at your calc and see the roots are imaginary. So it's up to you folks. If you're like, I love factor and I want to try to factor it, that's fine. And sometimes you'll still have to try to factor because on the last one, seeing that it was hitting the x-axis was not enough info to know if it was a fractional root or a rational root. So we have to go to the quadratic formula. X equals negative b plus or minus square root b squared, parentheses, minus 4 or 3, 8. Well, over 2 times 3. So we start underneath the square root. Negative 3 squared is 9. 9 minus 4 times 3 times 8. That's negative 87. Wow, I don't like that. Now, if we're trying to break that down, the very first thing we should do with that square root is what? Seeing that there's a negative underneath it. Take that I out immediately. So 87, off the top of my head, I'm not thinking of any factors. I can start to try to divide it by 2, by 3. Ooh, it is divisible by 3. Are 3 or 29 perfect squares?
No,
Can I break 29 down any further?
probably not.
No. So that's a no on being able to break it down into perfect squares. So we're stuck with that 87. Still got to bring out the I. Now from here, folks, I need to do division distribution. Folks, what's 3 divided by 6? 1/2. Then I have to take I radical 87 divided by 6. I cannot simplify that any further. But as you can see, division distribution was still required to get that 1/2 to be smaller. Can I do the plus minus case and add that imaginary stuff to the real stuff? No. So that's our final answer there. All right, folks, 27. Give it a shot.
Are you going to get negative?
Can you factor it?
Yes.
Yes. Now, if you said, I didn't want to, Mrs. Cairo, if we went straight to doing the quadratic formula here, I want to show you what happens. So, negative b plus minus square root, yada, 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 yada. Boom. We get the square root of 49. If you're looking at that going, well, I've heard about square factors, can I take out a 49? Folks, what is 49?
7.
49 itself is a perfect square. So the square root of 49 is just straight up 7. No more square root involved at all. From here, division distribution. Yuck. Negative 5/4 plus or minus 7/4. Ladies and gentlemen, can I add and subtract those two fractions?
Yeah.
Yes. So this is where I would have to do the plus case and the minus case. So negative 5/4 plus 7/4 and negative 5/4 minus 7/4. Using your calculator or doing it by hand, you would see that this is 2/4 or a half, and that this is negative 12/4 or negative 3. It is much more involved doing this with the quadratic formula versus factoring it. So I wanted to show you this way so you can see when the plus minus case comes into play. But ultimately, to avoid all of this headache, we could have just factored this using the x method. So 1x and 2x. Let's do 3 and 1. 1x times 1 is 1x. 2x times 3 is 6x. I need the 1 to be negative to get 5x, so I need this one to be negative. Do make sure, though, that you're checking to make sure you are getting the right sign on that product number. 3 times negative 1 is negative 3, so that is my correct pair of factors. So the x gets paired with the 3, the 2x gets paired with the negative 1, so x plus 3, 2x minus 1 equals 0. So setting those equal to 0, x equals negative 3, and x equals 1/2. So, which was more work? The quadratic formula is pretty involved. Having to do the plus minus case is annoying, so it is always in your best interest to try to factor first. Now, the other thing that may have pushed you to factoring is if you type that in on your calculator, 2x squared plus 5x minus 3. If I look at this on my calculator, yeah, that root doesn't look exact, but that looks like it's right on the money at negative 3. And if I hit trace, negative 3, we see that that's an x-intercept. If you can get a rational root, that means that you can factor it. Folks, I think that's it for me. You have the rest of the time to work on this and ask questions, but you've got everything you need to be successful on the final for tomorrow. Thursday, not tomorrow.